Hello everyone, it's Nicholas again. In this video I'm going to be reading a book called Get Eclipsed, The Complete Guide to the American Eclipse by Pat and Fred Espinac. I'm sorry if I'm butchering their last name. Okay, it's really late where I live. I'm so tired. I don't even know if I'm going to make that Science of Eclipses video today, but I definitely will be reading this book tonight. And, sharing it online as a video. I mean, it's still about science, it's still about eclipses, and this is literally all I have to urge you to do now. For whatever. Get Eclipse. The Complete Guide to the American Eclipse, August 21st, by Pat and Fred Espinac. The complete guide for this incredible event includes science and history of solar eclipses, science, fun facts for the entire family, helpful hints and safe viewing, maps and diagrams, information for partial eclipses in the United States, Canada, and Mexico, and much more. Designed by Brian Brock and William K. Chills. Where will you be for the greatest phenomenon of your lifetime? Do not be left in the dark wondering what just happened. Be prepared for one of the greatest. Please wait, I have to move my shadow. It's interfering with the light. I might just move this to the side. That just made it worse. Okay. For one of the greatest events of the century on August 21st, 2017. This could be the only total solar eclipse you will ever witness. I might just try and zoom this out, whatever. What is a total eclipse of the sun? Yeah, this is better. On August 21st, 2017, a total eclipse of the sun will be seen from a large part of the United States, stretching from coast to coast. But first things first, what exactly is a total eclipse of the sun? It is amazing, it can be scary, and is like nothing you have ever seen before. Day turns to an eerie twilight, there's a hole in the sky, and bright stars and planets can be seen during the daytime. It's something that cannot be described, you just have to see it with your own eyes. But what causes all of these things to happen? Well, that is an easier question. Here's a picture of it for those wondering. This is the total solar eclipse. Where I lived, we experienced a 97% of a partial solar eclipse and the path of totality. I know this book seems like it's for little kids. It probably was made for them, but it's educational at least, so whoever watches my channel is just free to listen to it if they want. The sun is 100 times bigger than Earth, and Earth is 4 times bigger than the moon. Even though the sun is 400 times bigger than the moon, it is also 400 times farther away from Earth than the moon. That means the sun and the moon appear the same size for us on Earth. That incredible coincidence is why we have total solar eclipses. And here's a picture of the moon and the sun. Oh, I'm sorry, that was the Earth down here. The moon's up here. In between the sun and the Earth. Okay. This is a plate that represents Earth as a peppercorn, a poppy seed representing the moon, and the whole plate is the sun. It's supposed to be about size difference between the three. Okay. Dinner plate, sun, as I said. The Earth is 7,926 miles, or 12,756 kilometers. In order to better... Okay, wait, I have to zoom out again. This is so annoying. Okay. In order to better visualize the scale of these bodies, imagine this. Take an ordinary dinner plate, one that is about 10 inches in diameter. That represents the sun. On this scale, Earth would be 1/10 of an inch, about the size of a peppercorn, and the moon would be even smaller, perhaps the size of a poppy seed. Remember, the peppercorn represents the world in which we live. That's pretty small compared to the dinner plate sun. Okay, next page. Page 5. Every year or two, the moon's orbit lines up perfectly, and the moon passes directly in front of the sun, revealing its faint cornea, the halo of plasma that surrounds the sun. That's when a total solar eclipse occurs somewhere on Earth. We say somewhere because the total eclipse is only visible from inside the path of the moon's umbral shadow. For those wondering, the umbra is basically the darkest part of a shadow, while the penumbra is the second darkest part of one. The shadow in which the moon blocks the entire sun as it swoops across our planet, this is called the path of totality. Basically, it's where we can see the eclipse. I'm not sure if it's for a lunar eclipse also, but I do know that's how it is for a solar eclipse. The sun is 865,000 miles, or 1,392,000 kilometers. Oh, I forgot for the moon. Let's see. The moon is 2,160 miles, or 3,476 kilometers. Page 6. The path of totality's diagram. I will show the diagram after I read this. The moon's umbral shadow crosses Earth during a total solar eclipse, creating the path of totality. The umbral shadow is quite small when it reaches Earth, so the part of our planet that is typically treated to a total eclipse is very small. About 0.3% of the Earth's entire surface, because this is the only continent, North America, that can see the eclipse this year, and the path of totality is basically only going through the United States. Okay, here's part of the diagram, and after part 2. You see the moon orbiting around the Earth, and then there's the Earth in the center of the page. Yeah, moon's orbiting Earth. The umbral shadow, which is the shadow the moon casts on the Earth, I believe, from where it blocks the sun's view. So all you see is the moon. And the shadow of the moon is why it blocks the sun. And the penumbral shadow, which is basically farther away from the umbral shadow. The path of totality explained, basically. Here it is, for anybody wondering, across 2 pages. Okay, next page. The moon has a second shadow called the penumbral shadow, and it is much larger than the umbra, or umbral shadow. The penumbral shadow is the shadow in which the moon blocks only part of the sun. People inside this large shadow will experience a partial eclipse. Basically, I today was inside the penumbral shadow instead of the umbral shadow. Okay, next page. If you are lucky enough to be in the path of totality on August 21st, 2017, you will never forget it because it's just something you see. Not just something you see. It's something you experience. Daylight is replaced by mysterious dusk, and bright planets and stars become visible. Planets and animals act as if though it was not a fall, not fail as flowers close up and birds return to roost. There's a chill in the air. This is true, I did feel a chill earlier when it started, because the temperature drops a dozen degrees or more. The brilliant sun is replaced by black orbs surrounded by a ghostly halo. The colors of sunset ring the horizon, and the hair on the back of your neck stands up. I forgot where I was. As though around you, you scream in amazement at the totally eclipsed sun. As you can see, there's page 8, and we're talking about the total solar eclipses effects. Page 9, I believe. I don't know if I'm going to read all of this tonight. My tablet's almost dead, but I will read 10 pages and read the rest in the morning probably after I charge my tablet. You can see here the phases of the eclipse, how it changes. It reminds me of the 8 phases of the moon, except for a short period of time, for those wondering. Okay, now let's read. All total eclipses begin and end with a partial eclipse. This is true. I experienced it. Okay, let me show you what it looks like for me. Right here, this phase of the moon, that's what I experienced at the most, where it was a 97% range for me. But I really hope I can experience this one day in another eclipse. Okay, continuing on. The entire event can take nearly 3 hours, but the total part of a solar eclipse usually lasts only about 2 to 3 minutes, so there's very little time to absorb the spectacular sight. This is what looks like that hole in the sky, the black disk of the moon with the sun's fiery corona or ring spreading out around in all directions. Because the sun is so bright, unless that fiery disk is blocked, the cornea is too faint to be seen. Oh, I forgot. As totality ends, a brilliant burst of sunlight appears along the edge of the sun. This is the diamond ring effect, and I did see that, except it was still partial. Since the corona and sunburst look like a celestial engagement ring. You can see here, it's just like a wedding ring you would find. Page 10. This is the last page I'm reading tonight. My tablet's about to die. Page 11 is about the history of eclipses. Page 10 is the last one for now about science. So, last one I'm reading tonight. See, history of eclipses, page 11. Okay, page 10. If you simply can't get into the path of totality, you'll still see an interesting show. The partial eclipse will be visible from everywhere in the United States, Canada, and Mexico. For example, in New York City, you will be treated to a 72% partial solar eclipse, and if you are in Memphis, Tennessee, you will get a whopping 94% partial solar eclipse. You see, for me, it was a 97% partial solar eclipse. I live close to that path of totality, which went across the country, but I don't live in it. Okay. If you happen to be lucky enough to be in a totality city, such as Charleston, South Carolina, you will get the overload, 100% of the sun completely covered during the total solar eclipse. Awesome! So if you can get to totality, you'll be glad you did. If you can't, you will still see an amazing sight, which is true. I did see an amazing sight, and after I finish reading this book, for the next 2 days probably, I will upload a slideshow of eclipse photos I took and videos. You just need to make sure you have a power of it doesn't really matter the company as long as it has the ISO mark, which means scientists have tested it to make sure it's safe. so I'm not going to read this sentence because it's about advertisement, but just says, have power of Eclipses, safe solar glasses with you. That was the kind I had, but that's only because it's the only kind I could find. Thank you for staying with me throughout this video tonight. Well, I guess it might not be nighttime for you, but it's for me. Continuing on, tonight for listening to this video about learning of the science of eclipses. Part 2 will be coming out either tomorrow morning or evening. It will probably be the last part. There's like 30 pages in this, but I plan on getting through on it tomorrow. I am too tired to read on, and I don't want to read on currently. Okay, I will be uploading soon a second science video, and it will be more science-based than just me reading from a sciencey book. It will be about probably earthquakes or volcanoes. There is a 90% of volcanoes being the next topic, 10% of earthquakes. Earthquakes might just be the third video. Yeah, I'm going to do volcanoes for the second science video. I'm planning on making a volcano model and showing it off and explaining how they work and what they are. I will also explain lunar eclipses in time, so this might just be the science of solar eclipses. Until then, I hope everyone has a nice day or night, wherever you are. Please like my videos if you like them, and subscribe for more content. Peace. This is Nicholas, signing out.